I want you to try a little mental exercise with me, just for a second. Picture yourself walking through a forest, say, 400 million years ago.
Okay.
You look up, but there are no leaves, no branches, no bark, just these massive, smooth tullers stretching up into the sky.
You'd be standing in the shadow of prototaxites. It's such a bizarre image, and for over a century, we couldn't even agree on what it was.
And we're not talking about small things here. These were the giants of their time, the absolute kings of the landscape.
But without a doubt, we're talking about organisms that could reach 8 meters tall.
That's over 26 feet.
Yeah.
And a meter wide. The crazy part is thinking about what else was around.
There was nothing else around, not at that scale. The other plant life, things like Cooksonia, they were maybe, 6 centimeters high?
So you have this green carpet of tiny plants, and then boom, these biological skyscrapers just shooting up out of the ground. It's like putting a redwood in a garden of moss.
And that's the paradox, right? How do you get something that huge that needs so much structural support before wood even exists?
Right. The first guy who found them, J.W. Dawson, he just assumed they were trees.
He did. Back in 1859, he called it Protaxites, which means first yew. He was convinced it was some kind of ancient, rotted conifer.
Which turned out to be completely wrong. Evolution hadn't gotten to tree trunks yet.
Not even close. If you look at it under a microscope, it's nothing like wood. It's a dense bundle of interwoven microscopic tubes.
Like fiber optic cables or something?
That's a great analogy. You have thick skeletal tubes for structure and then these thinner generative filaments weaving all through them. It's an incredibly complex system.
You know, that idea of managing millions of tiny interacting parts, it sort of reminds me of what our sponsor does.
A very good point. Managing complex networks is what Silk is all about.
Sure. If you're trying to coordinate things like AI training or automation or software integration, you know how tangled it can get. Silk can help you figure out where agents can make the biggest impact for your business. So check them out at embersilk.com.
So getting back to it, for the last maybe 20 years, we thought we had the prototaxites mystery solved.
Right, a fungus theory.
Yeah.
This is that big University of Chicago study from 2007.
Exactly. They looked at carbon isotopes in the fossils and found the ratios were all over the place.
Which means it wasn't photosynthesizing. Plants breathing the same air have consistent ratios.
Right. A varied ratio meant it was a heterotroph. It was eating things, probably rotting organic matter on the ground.
So, case closed. The world's largest mushroom. A 26-foot-tall mushroom.
That was the story. Until now, a new paper in Science Advances from just this month, January 2026, has completely flipped the script again.
This is what I love about science. So what did they find?
Well, it's more about what they didn't find. They did a chemical analysis on these beautifully preserved fossils from the Rhine chert, and there was no chitin.
No chitin, but that's the smoking gun, isn't it? Fungal cell walls are made of chitin.
It's their fundamental building block. So if you don't have chitin, it's very unlikely you're a fungus.
So it's not a tree, it's not algae, and now it's not a fungus. What's left?
That is the multi-million-dollar question. The paper suggests we could be looking at a whole new kind of life, something that doesn't fit our neat little boxes.
A lost kingdom.
Potentially. They also found the tubes inside thicken toward the base. That's a trick vascular plants use to support their weight. Fungi don't do that.
So it was engineered like a plant, but wasn't a plant. And it acted like a fungus, but wasn't a fungus.
It's like an evolutionary concept car. The paper floats the idea that it might be a mega rhizomorph, a massive complex system for moving nutrients across the landscape.
So it wasn't just a pillar, it was a highway.
A biological highway system, yeah. It created habitats. We find arthropod burrows in the fossils. It was cycling nutrients, preparing the soil, and basically building the infrastructure for the first true forests that would eventually replace it.
So it wasn't a failed experiment at all. It was the project that allowed the modern world to take root. That's actually a really beautiful way to think about it.
It is. It just reminds us that the history of life isn't some straight line. It's full of these incredible, creative, and sometimes just plain weird solutions that had their moment.
A moment when giants, whatever they were, truly walked the earth.
If you enjoyed this deep dive, please subscribe to the show. Hey, leave us a 5-star review if you can. It really does help get the word out. Thanks for tuning in.